Today, we're diving into a really interesting corner of physics that connects classical and quantum worlds, the quantum kicked top, a paradigmatic model. It sounds complex, but it's a foundational concept for understanding chaotic systems.
Precisely, Maya. This paper introduces the quantum kicked top, or QKT, as one of the most widely studied models in quantum chaos. It's a crucial system for understanding how chaotic behavior manifests even within quantum mechanics, a fascinating area.
A minimal yet powerful framework for quantum chaos sounds really intriguing. What exactly makes it so significant for researchers trying to bridge classical nonlinear dynamics with the often counterintuitive world of quantum behavior?
Its unique feature is having a finite-dimensional Hilbert space. Unlike many chaotic systems, where the state space can be infinite, this makes the QKT analytically and numerically controllable. That specific attribute is a huge advantage for in-depth study.
So, because it's analytically and numerically controllable, researchers can actually simulate and understand its behavior without getting bogged down in immense complexity. This unique characteristic must truly make it a prime testbed for new theories and models.
Right. The paper starts by deriving it from the classical kicked top. This involves analyzing its phase space structure, looking at fixed points, stability analysis, and Lyapunov exponents to thoroughly understand its classical chaotic dynamics before quantizing it.
How does that discrete nonlinear map governing the dynamics in the classical system translate into the quantum realm? Is there a direct quantum equivalent to these classical elements like bifurcations and Lyapunov exponents? Or is it interpreted differently?
The quantum description is developed using Floquet theory. Here, a periodically driven spin system is represented by a unitary Floquet operator. This operator acts directly on the finite-dimensional Hilbert space we discussed, defining the quantum evolution.
That's a powerful framework. So within this, they can observe signatures of quantum chaos, such as spectral statistics, and even entanglement generation. It really provides a clear setting to investigate the emergence of chaotic behavior in the semi-classical limit.
It even admits an interpretation as a system of interacting qubits. This has direct connections with modern quantum information measures through reduced density matrices and entanglement entropy. It's exciting for experimentalists building quantum computers, connecting theory to practical realizations.
It truly serves as a bridge between nonlinear classical dynamics, quantum chaos, and modern quantum information science. It's a fundamental model with incredibly broad implications across theoretical and applied quantum research, illuminating complex phenomena.
Understanding these foundational models often relies heavily on openly sharing research and its corresponding code. That brings us to our next source, which highlights the critical importance of open platforms for scientific work.
After delving into the quantum kicked top, it's natural to wonder where researchers share the practical code for such complex simulations. This page represents a common platform for that, GitHub, an essential tool in modern scientific collaboration.
Exactly. GitHub allows researchers to find code, projects, and people on GitHub. It serves as a central hub for version control and collaborative development, absolutely essential for fostering transparency and reproducibility across all computational scientific fields today.
Seeing open source prominently displayed, especially in the context of scientific work, immediately raises a question for me. What does this term truly signify for someone trying to understand or replicate intricate research, such as QKT simulations?
It fundamentally means the code is freely available, often under a permissive license, which actively fosters community engagement. You could even subscribe to our developer newsletter to stay updated on new features or contributions from others working on similar research problems, collectively building knowledge.
That makes complete sense. So it's not just about passively downloading code, it's about active engagement. A community forum would be an invaluable resource to ask specific questions, report potential bugs, or even suggest meaningful improvements for a given reference implementation.
Absolutely. Beyond mere code, good open source projects invariably include comprehensive docs. These resources are absolutely crucial for understanding how to properly set up the development environment, execute the code, and accurately interpret the results, which is vital for complex scientific models.
And the existence of a developer API suggests a significant level of maturity and extensibility for the GitHub platform itself. This feature enables other tools and services to seamlessly integrate, significantly enhancing the broader ecosystem available for shared research projects.
Precisely. The entire platform fundamentally operates on Git, which is a robust, distributed version control system. Understanding what is Git is absolutely foundational for effective collaboration, meticulously tracking all changes, and ultimately ensuring the integrity and lineage of any shared research code over time.
So even though this specific page is generic, it powerfully highlights how platforms like GitHub build an entire ecosystem that underpins modern scientific research. It's more than just file storage. It's a living, breathing network for innovation and knowledge exchange.
While this page gives us a glimpse into GitHub as a company and its corporate structure, the crucial takeaway is its profound role as a facilitator. These platforms are indispensable for disseminating complex theoretical work and ensuring its practical accessibility to the wider scientific community.
It truly underscores that the impact of a complex theoretical model like the quantum-kicked top is amplified exponentially when its practical implementations and discussions are made openly available through such robust platforms.
Indeed, they ensure that cutting-edge research can be explored, validated, and built upon by a global community. This open approach accelerates understanding. I'm Arjun. The next walkthrough is in 3 hours. See you then.
And I'm Maya. Thanks for spending this with us.